Hello everyone, welcome you all in this lecture series of digital electronics, and today's topic is types of flip-flop. These are the various types of flip-flop like RS flip-flop circuit, clocked RS flip-flop circuit, D flip-flop, JK flip-flop, T flip-flop. In this video, I will explain you about RS flip-flop and clocked RS flip-flop circuit. RS flip-flop. RS means R is for reset and S is for set. So definition of this RS flip-flop is a circuit containing cross-coupled connection which is used to remain a memory state stable by using asynchronous sequential circuits is called direct coupled or RS flip-flop circuit. As I told you earlier about asynchronous circuits where the clock does not apply. Explanation about this flip-flop that it has two inputs and two outputs. Inputs are denoted by R and S and outputs are denoted by Q and Q bar. And these flip-flops can be implemented by using NOR and NAND gate. This is the block diagram for RS flip-flop circuit and this is truth table for this flip-flop. As you can see here that for S and R inputs there are four input condition. First input condition is 0 and 0 when S and R are 0 and 0. So the action will be taken by this RS flip-flop circuit is no change. No change means that the output is in the same as its previous condition. Okay, so consider another condition is 0 and 1. 0 and 1, it means set is equals to 0 and reset is equals to 1. So the action will be taken by this flip-flop is reset. S is 1 and when R is 0. So set condition is 1. So action is going to be held set. Next condition is when S and R is 1 and 1. So this condition is undefined because both Q and Q bar are equals to 0 at this condition. So this can't be possible because Q and Q bar both are inverted of each other. Okay, so let's take first condition when we want to set the output. Okay, we want Q is equals to 1 and we think that Q is equals to 0 in previous case. So for set condition S is also 1, S is also 1 and R is going to 0. Okay, S is 1, Q previous state is 0. So 0 comes here. So we have 1 and 0. So NOR output of 1 and 0 input is 0. So Q bar is 0. Okay, Q bar is 0. So this 0 goes here. Okay, 0 and R value is also 0. So 0 and 0 NOR condition output is 1. So Q will be 1. Okay, so now the output is 1 and 0. So this condition is called as set condition. So this is the overall working of RS flip-flop. Now next thing is clocked SR flip-flop. In this circuit, there is a small change that we are going to apply a clock signal with S and R inputs. Okay, so we can see it's a diagram. Clock signal is what? Here is a block diagram of this clocked SR circuit. So as you can see here that we have two same inputs S and R with another input that is called clock. So S and clock input is applied to this NAND gate. This clock and R is applied to this NAND gate and another circuit is a cross-coupled structure. Okay, cross-coupled structure. So in this waveform, you can see that clock is a signal of periodic signal of 1 and 0 terms. Okay, like this is 0 1 0 1 0 1 means turn off, turn on, turn off, turn on condition. S and R are inputs. Okay, Q and Q bar are the outputs when clocked is applied. Okay, another Q and Q bar are the outputs when positive ACE triggered is applied. Okay, let me tell you here what is ACE trigger circuit and another one is level trigger circuit. Okay, ACE trigger circuit is when when a circuit gets activate at particular this point. Okay, this point is the A's of the signal, A's of the signal. Another point is this one, this is the A's of the signal. Another point is this. Okay, so here clock is going from 0 to level 1. So it 0 to level 1 is called positive ACE trigger, and at this position clock signal is going from 1 to 0. Okay, so this is called as negative ACE trigger. So here this is the output for positive ACE trigger. So at this position, okay, so we just take this example. Here you can see at this positive ACE triggered, okay, positive ACE triggered, S value is 1 and R value is 0. So when S is 1 and R is 0, so output should be 1. So here Q is 1, okay, and Q bar is 0. Okay, next, now this output will be okay, this next output will come at another positive ACE triggered signal. So here this is first positive ACE triggered signal, this is negative ACE, and this one is positive ACE triggered. So here S is 0 and R is also 0, so it retains its previous condition. Okay, so here Q previous condition is at level 1, so at this positive ACE triggered, its value is also 1. Now this is negative ACE triggered and this is another positive ACE triggered. So at this position S is 0 and reset is 1. So Q is 0. At this condition Q would be 0 and Q bar would be at level 1. So this is the overall working of SR circuit. That's all for today. Thank you.